Hi everyone. This is the last video on polynomials, you'll be pleased to know. What we're going to look at in this video is factorizing and solving cubic equations. So we've just looked at graphing cubics and other polynomials. What we're going to be doing here is just showing you how to factorize them. So just to go over a couple of bits of terminology again. Just remember, if you've got something that looks like this, x plus 1 times x plus 2 times x plus 3, and you turn it into something that looks like this, we call that expansion. Most of you are quite good at that. If we're going back the other way, that's what we call factorization. So the process of factorizing a cubic is fairly similar to how we factorize a quadratic. In fact, the trick with factorizing a cubic is first of all to take a linear factor out so that you get left behind with a quadratic, and then we factorize the quadratic. Okay, so I'm just going to go through basically just do this by example because I think that's the easiest way to explain it. So first of all, let's have an equation y equals x cubed plus 4x squared take 5x, and I want to factorize this equation. So it is a cubic because it's got an x cubed, but what you'll notice is that every term in this equation has an x in it. What that means is that there's no constant. So this makes our life fairly simple because straight away we can take out x as a common factor and then divide the whole equation through by x, and that's what gets left in the brackets. Now, in the brackets, we have a quadratic equation. All we have to do is factorize that quadratic, and we've factorized the whole thing. So if I go to -5 and think about it, what are two numbers that multiply together to give me -5 and add together to give me +4? Well, I would say that a good guess is 5 and -1 because they add together to give us 4. So I'm going to write x plus 5 times x take 1. And there we go. That's in factorized form. Okay. So this process is one that you can use when you've got an x in every single term of the equation. Okay, I'm going to do another example. So in this example, we have a function y equals 2x cubed plus 15x squared plus 22x take 15. And we want to factorize this if 2x take 1 is a factor. So really important thing here, if we had just been told to factorize this cubic on its own, that would be very difficult. But what we'll often do is we'll know one of the factors already, which makes it a bit easier to actually factorize. So what we're going to do is I'm going to write out this again, and then I'm going to write my first factor, which is 2x take 1. Since that's a linear equation, I know that that's got to be multiplied by a quadratic, but I don't know what that quadratic is, so I'm just going to write ax squared plus bx plus c. What the trick is now is just to figure out the values for a, b, and c. So to do that, I'm going to actually expand this out. So 2x times ax squared is 2ax squared. 2x times bx is 2bx squared. 2x times c is plus 2xc. And then the negative 1 gives me negative ax squared, take bx, take c. Now what I'm going to do is collect up the like terms. So, this first one should actually be 2ax cubed because it's 2x times ax squared. So that's my only x cubed term. Now I'm going to add together my two x squared terms, so 2b and negative a. So that'll be 2b take a, x squared. I'm going to collect together my x terms, so that's 2c and negative b. And then my constant is this value on the end, which is negative c. Okay, now I'm going to go back to, remember the idea of polynomial equality. If this polynomial over here equals this polynomial over here, then all of the coefficients have to be equal. So this 2 must equal 2a, this 15 must equal 2b take a, 22 must equal 2c take b, and negative 15 must equal negative c. So that should be fairly straightforward. So if we look at 2 and 2a being equal, 2 equals 2a, that tells us that a equals 1. If we look at our constant, we've got negative c equals negative 15. So c equals 15. If we look at our coefficient of x squared, 2b minus a equals 15. We know that a is 1, so 2b take 1 equals 15. So 2b equals 16, and therefore b equals 8. Now that's actually given us a, b, and c. We can just double check that by looking at the fourth coefficient here. So 2c take b, and I've just realized that should have been an x there as well. 2c take b equals 22, and let's just check that 2 times c is 2 times 15, take b, which is 8, equals 22, so that's 30 take 8, and we know that that equals 22, so we must be on the right track. So what we can do now is we can actually write this in factorized form. So y equals 2x take 1 multiplied by a quadratic equation where a is 1, so I can just go straight to x squared, b is 8, and c is 15. And then to get this fully factorized, I just need to factorize that quadratic on the end. So two numbers that multiply together to give me 15 and add together to give me 8 are going to be 5 and 3. And there we go, we've got it in a factorized form. So the process here, just remember, we knew what one of the factors was, so we wrote that down straight away. We then had an unknown quadratic, so we just wrote that in terms of a, b, and c. We expanded that out, and then we equated all of the coefficients in order to figure out what a, b, and c are. And then at the end, it was just a process of writing that quadratic and then factorizing the quadratic. I'm going to do one more example on this. So in my last example, I'm going to say that x equals 2 is a solution of 2x cubed plus 7x squared take 10x take 24. And I'm going to say that we want to find the remaining solutions. So the process for answering this question is exactly the same as what we've just done. This time we know that x equals 2 is a solution, and that tells us that x take 2 is going to be a factor. So if we write out that polynomial again, we can say that that's going to be equal to x take 2 multiplied by some sort of quadratic, ax squared plus bx plus c. And I'm just going to expand that again. So same as what we did in the last example. So that's going to be ax cubed plus bx squared plus cx, take 2a x squared, take 2bx, take 2c. And then I'm going to group up my terms. There's only one cubed term. For x squared, I've got b take 2a. For for x, I've got c take 2b. And for my constant, I've got negative 2c. So I'm just going to do this in a slightly different order this time. Let's look at the coefficient of x cubed first, and that's normally easiest because there's only going to be one of those terms. So straight away I can see that 2 must equal a, so a equals 2. If I look at my coefficient of x squared, b take 2a equals 7. So that means that b take 2 times 2 equals 7. B take 4 equals 7. If I add 4 to both sides, b must equal 11. And then to get my value of c, I'm just going to jump to this very final term, which says that negative 2c equals negative 24. And if I divide both sides by negative 2, then I get c equals 12. So I've actually got a, b, and c already. I don't even need to do this last one, but I may as well do it anyway just to check. So c take 2b equals 12 take 2 times 11, and that's 12 take 22, which is negative 10, as we would expect. So we've got that right. So I'm going to write this out again and say that y equals x take 2, which is my first factor that I already knew. And now I can fill in my quadratic. So that a is going to be 2x squared plus b, which is 11x, plus c, which is 12. Now I just need to factorize this. So remember, factorizing a quadratic like this is a little bit trickier because I've got a coefficient of the x squared. So I'm going to straight away draw a little table with 2x and x. And then I'm going to look at the factors of 12. So I've got 6 and 2, or 3 and 4. Let's have a look at these. So 2x times 2 cross multiplying is 4x. X times 6 is 6x. That gives us 10x. So that's not really what we want. But if I do the second one, x times 3 is 3x. 2x times 4 is 8x. If we add those together, that gives me 11x. So that's that one there. Is the one that we want because it gives us 11x, okay? So then we just pair that up with our 2x and our x. So we have x take 2 times 2x plus 3 times x plus 4. If that last process didn't make any sense, then just go back through the quadratic videos. Okay, that's it. Thanks for watching.